Hello. Thank you for being here, and thank you for having me here. I am here to talk about, definitely, Take On Me, the song you just heard. Well, this song has some really catchy music, as you noticed, but also it has some wonderful animations. It's a very old song from the 80s by a Norwegian band called Aha. I'm not necessarily going to talk here about the music, because it's not really my thing, but I'm going to talk about the wow animations that it has, because I'm all into wow animations. It's like my life goal to make these things on weekends, like grab Harry Potter's code and animate it with gradients in CSS, because why wouldn't you do that if you can? So hi, I'm Eva, or Eva or Eva, whatever you can pronounce is OK. I'm a front-end developer by day and a protector of useless creativity at night. And also a Mozilla Tech speaker and the organizer of CSS Conf Argentina. And by the way, my name is actually that, but it's kind of too difficult. So what is this thing? Well, this is something called rotoscoping. It's a very old animation technique. It has about 100 years old. And it kind of came back from the old movies into music videos with this song by Aha in 1985. But it wasn't the only time it was used in music videos, because after that, we can actually find it in Green Day a couple of years later, and in Lily Allen's video, and also in a Paramore video in 2017. And again, because Paramore definitely loves this, in another one called Caught in the Middle the year after. And let us not forget the wonderful Justin Bieber and Ed Sheeran using that very technique this year. So how does it work? Well, it's pretty simple if you actually look at it. You record a video, a completely normal video, and then you start drawing on that video. You have to draw a lot, like 15 to 25 images per second. So maybe you just spend like 3 hours drawing, and then suddenly you press play, and it's only 3 seconds of animation. And it's like, well, it will be the first 3 seconds of your life. So you can turn something like this, which looks really boring and what is going on, into this, which is really cool. And well, right now it's done with a Wacom tablet and Adobe Photoshop, but you can also use any other software or even your computer if you don't have one of those tablets. What I was trying to come up with the idea of what I can do in the web, in this, like 2017, this video came out, Hard Times by Paramore, and it's kind of helped me to get back into animation. That's something that I always love. And I start wondering, what is it that we have right now on the web of traditional animation that we can use? Because the truth is that in 2010, we began working with keyframes animations and eventually with JavaScript animation. And we took many things from traditional animation, from movies and from the cinema, and put them on the web. And it's amazing what we have done, because suddenly we can make stop motions and motion graphics, which are things that are not native from the web. They are taken from the cinema, they are taken from the movies, and we can use them without any issues on the web. If you're looking, for example, I highly recommend Rachel Nabors when you want to learn something about stop motion. She began speaking a couple of years ago, and she showed this wonderful way of making stop-motion animations on the web. She has a lot of videos on YouTube that you can actually watch, and she also has a few courses online. And when it comes to stop-motion, to motion graphics, it's just vector animation. In this case, Chris Gannon, you can Google him and find him on CodePen. He actually does a lot of funny and interesting animations in JavaScript with SVG. And also, let us not forget, yesterday, Julia gave a talk about how to make these kind of interesting animations using CSS. So my question actually is, can we go further? Can we do something else? Can we take another animation technique from the original animations of the 19,000s and use it online? Can we make rotoscoping on the web? Well, the answer is no, we can't. Why? Well, because rotoscoping is such a beautiful thing. It's handmade, it's like artisan, and it carries the soul of the one that draws these pictures. My computer is beautiful. I love it. It's called Minerva. It even has a name. But it doesn't have a soul. Don't say it, but it doesn't. So it's not necessarily possible to make something exactly the same as it is rotoscoping, because there's no human behind. But nevertheless, we can take the rotoscoping idea into our web world. And it's something really interesting because we can take advantage of the world that is interactive. If we take a look at the AHA video, the video is not interactive. You watch it, you fall in love with the love story in the video, you really enjoy the animations, you dance to the music, but that's it. You cannot click on it, you cannot drag something, you cannot really interact. But in the web, we can actually interact, so we can take advantage of that and try to mix these things together. So if we take a look at this part of the hard times video, we actually see something very interesting. We see layers. So in the background layer, what we see is a kind of an animation of blue and yellow. Then there is another layer where you can actually see these two people dancing, and on top of them, a third layer with these kind of lines drawn on top. So this is a kind of simple example of rotoscoping. And if we look at the behind the scenes, we see this, which is really fun when you look at the behind the scenes and how it was recorded. So they took this video and they removed the backgrounds. They put that background of blue and yellow. Then they reversed the video. I don't know if you noticed, but the video is actually reversed. And then they draw on top. So it's pretty good. And we can do something like this. We can play with this, because this is something called Chroma key. That is actually something that you may know from movies, like action movies, like Avengers. They record something in a green screen, then they remove this green screen and they put something instead. So Chroma key works with either green screen or blue screen. Nothing other than green or blue, because it basically works in our case with RGB. And the other difference that green or blue is red. And it turns out like our faces are pretty red, so it's not a good idea to use red. That's why we use the other two. And you need really good light, and I mean really good light, to make this work, because the light helps to recognize the colors. When it is really dark and you can barely see, you will notice that you will see the objects, but they will be gray. Because the first thing that you lose when there is low light is the colors. You see the object, but not the colors. So we need really good light. And natural light is the devil. It's like the worst that you can do whenever you are working with animation, whether it is stop motion or this chroma key. Because basically, it may take you a lot of hours to make an animation. And if you spend 6 hours with natural light recording an animation, basically the Earth moves, you know? And that will mean that in these 6 hours that you spend, the shadows move. And then you put it all together, and the shadows begin to act weird. And so natural light is like the worst thing you can do. Try to avoid it. This is much better. So we will be working with chroma key, but using the camera's input. Because that's the interesting thing of the web. You can actually use different input, and you don't have to always use a certain video. So to do this, we need to follow certain steps. The first one is to take the user's camera input and put it into a video tag. Then we will copy that input of the video tag into a canvas tag. And then we will process the canvas. We will find the green or blue pixels, and we will remove them and add whatever we want in the background. So first step, take the user's camera input. We can do this natively in every browser with Get User Media. We can identify which things we want from the user's media. In this case, only the video. We are not interested in the microphone or anything like that. So we set to video true, and this will return a promise. If it works, we will put this content into our video tag using this function. So whatever the video is streaming from the camera, we will put it into our video tag. If it fails, we just throw an error. This works pretty well. Let me show you. So what you will see is this kind of banner alert that will ask you, hey, do you want to share the camera? And you will say, yes, and it works. Awesome. So then, next step, take this video input and copy into the canvas. So we need a canvas. canvas ID canvas, that's pretty much it. We allow the 2D use, and then we create a function. It can be called draw or something else. We draw an image inside this canvas, which is CTX1, and we copy into this canvas the video. So from the top left corner, which is 0, 0, until the width and height of the video, we copy every frame, every pixel of the video into our canvas. Now, this won't necessarily work, because if we use the codes like this, what we will get is only the first frame of the video, because the video from the camera will keep on streaming all the time, and the canvas will have a stop in the first one. So we need to actually refresh this. Now, performance expert will hate me, but we can use a set timeout with 0 and call this function all the time. It's fun, it works, that's the important thing. So you get something like this. On the left, you have the original video, and on the right, the canvas. So you get my cat. And that means exactly the same content on one side and on the other side. Next, we need to process the canvas. So we will remove green or blue. And for this, we need to talk about something called pixel manipulation. Now I know we are in a front-end conference, so we actually know what is a pixel, but let's take a closer look, just in case. So a pixel is the tiniest part of an image. If we take a look at this, we can say that this is a pixel. It's the smallest part that there is over there. And this has a color. So the color is given to us in RGB format. That means that this pink is actually composed by this red, plus this green, plus that blue. So all these colors together return us this pink. And RGB has a value. This value ranges from 0 to 255. 0 is complete black. And 255 is the strongest red, the strongest green, and the strongest blue. So in this case, we have a very strong red, we have a very dark green, and we have a kind of in the middle blue. And also, we got the alpha channel. Now, the alpha channel is transparency. In images, we know we can have transparencies. We can use a PNG format, and we will see the background. But in videos, we don't have such a thing as transparency. But anyway, we still get the transparency values when we ask for video information. So what we will get is the red value, green value, blue value, and the alpha value, even though it will always return 255, unless we change it. And that's the interesting part. So to make Chroma happen, we need to find the green pixels and remove them. But in fact, we don't really remove them. We just turn the alpha into 0. So to find the green pixels, we need to ask for the information of those pixels in the canvas. So we got something called getImageData that will return all the information of every pixel in that canvas. So I want to recommend this, but I actually did a console log of that. So when you do a console log of this, you get something like that, which means, OK, you have a width of 640 pixels, we have a height of 480, and then here's at you an array of 1.2 million dots. That sounds like a lot. And it sounds like such a random number, but it isn't. This 1.2 million is actually the height of the video multiplied by the width of the video multiplied 4, because 4 is the number of information that we get for each pixel, the red, green, blue, and the alpha value. So if we start opening this array, and again, we suddenly get to the values. They look random at first, but there is a sequence, and that sequence is a 255. So we know that this is the alpha value because there is no transparency in videos. And if that is the alpha value, that means that we can identify the other values. Is RGBA, RGBA, RGBA of each one and every pixel that you have in that canvas. So that means if we take a look at this first pixel, we get the information of something like this. It's an RGBA of 55, 74, and 86 with 1 of opacity. That means it looks something like this. It's kind of bluish, but very dark. So we can work with this. We can actually go through all this data and find the green pixels. So we will ask if the green is bigger than the red and if the green is bigger than the blue. If that is the case, what we are going to do is we are going to grab the alpha value of that pixel and we are going to turn it into 0. And then you need to return this into the canvas again, because you changed the information, so now you put it back. So you put it back with put image data. And you get something like this. Now, let's not cheat ourselves. This doesn't look good at all. So there are kind of two issues over here. My wall is completely gone, like only half of my wall is green, and the other half isn't, but nevertheless it's like gone. And there is something weird with my hair, and my hair is not green as far as I know, but it exists away anyway. So we have two things to fix. The first one is better light. That was natural light. That is the devil. You don't use natural light. So you need better light, and then you also need to remove only if the color you are looking for, in this case the green, is bigger than maybe 100, because that way you're actually certain that the green is really green and not a dark color. When it is dark, when the value is really low, you cannot be sure if that is green or whether it is a brown or a gray. So it's better to be certain and to say, okay, remove only if green is bigger than 100. And we get something like this, which is much better. It's still not perfect, but my hair is okay. That's not natural light. And there is something really weird with my t-shirt. I know what you're going to say. It's a Harry Potter t-shirt. It's magic. Yes, but also, it's not only magic, it's white. And there is a huge problem with white things, because they take the colors of the surroundings. So it ends up being something like green. So it was either I modify my code or I change my t-shirt. Guess what? I changed my t-shirt. So if you change your t-shirt, it works perfectly, you see? Wonderful. You don't need to modify your code at all. So let's try this. All right, let's see if it works. We're over here. On the left, the original video. On the right, the canvas. And of course, a Hogwarts image. What are you going to put? If you can be somewhere else, it will be Hogwarts. So let's try. I'm there. Can you see me? Yeah, great. I got something green. You always need to travel with something green. And yeah, I'm in Hogwarts. You can totally be anywhere you want. Hogwarts, not Hogwarts. Yay! It's great. Thank you. And you can also I put a drop-down in here to select whether you want to filter green or blue. You can also filter blue. Blue is a little bit more complicated because it's kind of more dark. But we'll see. Let's see. Be nice, be nice. We are in the middle of a conference. There you go. So we also got blue. And what you can also do with this, which is amazing, because I don't know if you noticed, but I'm a Harry Potter fan, you can actually do an invisibility cloak, because why wouldn't you, again? To do an invisibility cloak, what you need is to modify the background. So it's not Hogwarts, but my background without me. So I'm going to take a picture of the background without me. I'm using another camera. Let's change cameras. Is this camera over here? So it might not work that well because of those lines, but let's try. OK, so I got the picture. Now I go look for that picture in my wonderful computer. I copy that picture, and I take it into my code in here next to the Hogwarts one. Then you copy the name. I modify your code a little bit. So here is the background image. You replace Hogwarts with this image. Now you do this. You choose the other camera. And hopefully it will work. Let's see. Can I disappear or not? Probably not, but let's try again. Yes, allow the use of the camera, and we will disappear, hopefully. Let's try. It's in green. I barely see what I'm doing. That's really interesting. It's not working because I'm not in the camera. There you go. Can we get a little more light? because I need to do something really silly. We got green. Light is not with us. Okay, something like that. So you need a little bit better light, and you need definitely to avoid those lines that are moving over there. But that's because of the screen and the projector. So basically, you can do an invisibility cloak. It's a really nice costume to wear anywhere you want. It kind of looks too green, perhaps, but it's wonderful, I assure you. So let's go again. After this, we can actually do something more. We can do more manipulation. And again, I love this video. I love this whole album by Paramore. The same video, Hard Times Again. So this is the singer dancing in the middle. And then there are like 2 images of her in purple or pink. So these are actually 100% rotoscoping. They are handmade. But we can do something like that. I won't dance. Taylor Swift will dance. So Taylor Swift dancing with the green background. We will take this as an input, not the camera. And then we will, again, remove the background. And we will triplicate Taylor Swift. So now we have 3 Taylor Swift. And I apply a really tiny transform to actually shrink the other 2. So it has kind of a nicer effect. To do this, you actually replicate what you are seeing in the first canvas into the other 2. So you can have 3 canvas and just copy the content. And then you need to turn them pink. But what's interesting is that we have an if statement, a conditional. The conditional was used to filter the green. In this case, we don't want to modify the green because the green is gone. What we want to do is to modify what is left. So we will use the else statement to modify that. And we want it purple, pink. So if we want something to be kind of purple or kind of pink, we can do something like blue plus red. If you put blue plus red, then you get that color. So what we are going to do is whatever wasn't removed, so the else statement, will be turned into 200 for the red value and for the blue value. So that's how you get this pink. Now we can try it, and it works pretty well. And if you want to make it better, you just put a bunch of kittens, because they always make everything better. Or, since we are in a development conference, you put React logos, because every conference should have some React logos. Thank you. So I know this isn't rotoscoping, but again, rotoscoping is such a beautiful thing that a computer cannot do yet. But it's pretty much something that looks like it, and that gives us like endless possibilities. And it runs in your browser, and it doesn't need any other software. You don't need to download like Adobe Photoshop or After Effects. It's fine, you got your software. So thank you very much. I will leave you with a bunch of links with the slides, with the Chroma key online. I wouldn't open it on my phone if I were you, because it crashed mine. The GitHub repo, in case you want to send a pull request, they are always welcome. And my Twitter if you want to ask something. Thank you very much.
OK, please welcome here.
Yep.
And here we have our questions.
What about semi-transparent and opaque scenes, as example, glass?
Semi-transparent elements. Oh, well, you're in trouble. I don't know if that's the right answer. If you want to make something like this with a background, and you're probably going to do that without JavaScript in After Effects or another software that, for now, it's more advanced.
Do you know any examples of this for practical usage? Or is it only for fun?
Honestly, it's for fun, but I believe there should be a practical use. We just haven't seen it yet. It's only a matter of time.
OK.
What about performance of your examples?
Well, I believe, I mean, it's not really performant. It did crash my phone, but I really highly believe that you can actually improve it. I mean, if you refactor it, probably will learn so much better. And so it's something like, it's not really good right now, but it's something that you can actually work on.
Okay, and what are the most unusual or crazy videos that you made?
I think this is a crazy thing that I did, yeah.
Okay, then serious question. Are there any algorithms or approaches that solve the problem with greenish-bluish color of skin and things to improve quality?
You can modify a little bit the filters. In fact, something that I wanted to do and I didn't have the time was like in a slider, so you can actually pick how much blue or how much green or how much red you wanted to filter. So that would probably work. I mean, this code is really strict with 100 of green, but it's something that you could actually work on.
And last question, Gryffindor or Slytherin?
Slytherin.
Thank you very much.
Thank you.
Thank you.